Hi, welcome back to the course. In this video, let us install the TypeScript globally. Open terminal. If you're on Windows, open the command prompt and execute the following command: npm install -g, which is nothing but globally, followed by TypeScript. This is going to install the TypeScript globally. In case if you're not able to install it, just add sudo at the beginning. This will install and it will ask you to enter the admin password. Enter the admin password and then you can install the TypeScript. Once you install the TypeScript, you can verify it by executing the command tsc --version, and you will see the version that you have installed. In my case, I have installed 5.5.4. In your case, it might be a different version, but as long as if you see the version number, then you're good to go. You have installed TypeScript in your system. Okay, next, let's create a new TypeScript project. I have opened the folder TypeScript playground, and inside this we can initialize the npm. First we need to open the terminal. I'm going to open the integrated terminal within the Visual Studio Code. Click on this terminal and click on this new terminal. Let me clear this, and now let's initialize the npm init. We can add the -y flag, so it is going to generate the package.json file with the default values. And if you open the file, you can see it has generated this package.json file with all the default values. The name is TypeScript Playground, version is 1.0.0, description it has been empty, and main it is added as index.js, and we have some script stacks. So for now I'm going to remove this. Alright, let me save this. So now we have initialized the npm. Next what we can do is we can install the TypeScript inside this package.json file. So what I'll do is I'm going to execute the command. Let's clear this. And npm, earlier we have installed it globally, now we have to install it within this project. So for that I'm going to install the TypeScript, npm install TypeScript. I'm going to install it as a dev dependency. You can add this flag --save -dev. It is going to download this dependency and it is going to register it inside the dev dependencies of the package.json file. If you open the package.json file, and you can see inside this dev dependency, it has added the TypeScript, and we are going to use this TypeScript only for the development purpose. So that's why we have added it as a dev dependency. Okay, next we need to also initialize the TypeScript compiler. So for that we can execute the command tsc --init. It is going to initialize the TypeScript compiler with the default values. So you can see tsconfig.json file has been created. If you open this, and you can see we have a lot of options to customize this TypeScript compiler. We are not going to touch all of these properties, that is irrelevant to us. A few properties we're going to touch, that is the root directory. I'm going to enable this. I'm going to specify the root directory as src. Of course, we haven't created this folder. We're going to create it in just a bit. And next we have the output directory. So you can see we have this output directory. We have to tell where we're going to generate the JavaScript files when we compile the TypeScript. I'm going to enable this comment and we're going to specify dist. Let me save this, and that's all. Rest everything you can leave as it is. And now inside the project, let's create a root of the project. Let's create a new folder, src. Inside this src folder, we are going to create the TypeScript file. Okay, so let's create a new file inside the src. Let's call this index.ts. Okay, we already know that what is a TypeScript. TypeScript is a superset of JavaScript. Any valid JavaScript code is also a valid TypeScript code, right? So let's log to a simple message to the console. Hello world. This is a valid JavaScript code, which means it is a valid TypeScript code as well. So let me save this. Now this is in the TypeScript file. Now we have to compile it. So it is going to generate the equivalent JavaScript file. So let's see how we can do that. Let me clear this. In order to compile this, all we need to do is we just need to type tsc from the root of the project and hit enter. It is going to generate the dist folder that we have specified inside our tsconfig.json file. And if you open this, you can see it has generated the JS file with the same name, index.js. And if you open this, you will see the same code, which is console.log hello world. Now if I want to run this code, we can type node and we can just type the file name, which is index.js, hit enter. Oops, node, and we have to type dist /index.js, and you can see we see the message hello world. Alright, so now we have installed the TypeScript, and also we have created the TypeScript project, and we have configured the npm, we have configured the TypeScript compiler, and we also see whether it is working or not. Alright, in the next video, let's install a few more dependencies and we can start learning the basics of TypeScript. Let's continue in the next video. In this video, let us install the 2 more dependencies. We're going to install the Nodemon as well as the TypeScript node. We're going to install the Nodemon because when we start the application, the Nodemon, what it will do is it is going to start the application in a watch mode so that we can write the TypeScript code and we can see the output in the live mode itself. So that is why we are going to use the Nodemon, and the TS node is a supported dependency for that. Let's install the necessary dependencies. Npm install TS node and Nodemon and hit enter. It is going to install these 2 dependencies. And that's it. We need to configure it now. Let's go to the package.json file. Inside the scripts tag, we have the scripts tag. Inside this, let's define the script for start, and we can specify Nodemon, and we can specify the file name src/index.js, index.ts. That's it. Now let me save this. Now we need to run this. Npm run start and hit enter. We can see this message hello world, which is present inside this index.ts. So I'm going to just add exclamatory mark and press save. You can see in the real time hello world with exclamatory marks. So now we don't have to necessarily stop the server and we have to compile the TypeScript, and it is going to generate the JavaScript files, and then we can run the JavaScript files. We can directly use this Nodemon to see the changes in the real time. In the next video, we can start learning the basics of TypeScript. Let's continue in the next video. In this video, at a high level, let's discuss what is TypeScript and what are some of its features. Also, let's discuss the key differences between TypeScript and JavaScript. First of all, TypeScript is an open source programming language. It is developed and maintained by Microsoft. Microsoft is the whole and soul for the creator of this TypeScript. They are the one who created this programming language, and they have made it open source, and it is maintained by the Microsoft team. And it is a superset of JavaScript, meaning any valid JavaScript code is also a valid TypeScript code. If you are writing the JavaScript code which is valid, then obviously it is a valid TypeScript code. There is no doubt about it, because it is a superset of the JavaScript. And some of its features are it provides the static typing, classes, interface, and bunch of other features it provides, so that it will improve the development experience, and it will also provide the robustness of the language. Let's discuss some of the key differences between TypeScript and JavaScript. The first difference is static typing. When it comes to JavaScript, we know that JavaScript is a dynamically typed language, meaning the variable types are determined at the runtime. So if we declare a variable and if we have provided the value to that variable at the runtime, it is going to determine that type. Until unless it is not going to determine it. But in TypeScript, when it comes to TypeScript, TypeScript is a statically typed language, which means the variable types are declared and checked at the compile time. We can take an example of this. At the bottom, I'm going to declare a variable, let age is equal to 30. Let me write age is equal to 30, and as we said before, the TypeScript is a statically typed language, so that I'm going to provide the variable type, which is number. Now, if I try to reassign a value to this age, if I try to reassign a string value or a string, then you can see the TypeScript compiler will throw the error that is type string is not assignable to a type the number, because this age is of type number and we are trying to assign the string to the variable, and it is happening at the compile time. We are not running the application, so it is just in the compile time the TypeScript is compiling that. But in case of, let me remove this, but in case of the JavaScript, if I go to the project explorer and if I create a new file inside the project, just say test.js and let age is equal to 30, and I can just say age is equal to my age. See here, in this case we are not getting any errors. We can still run this file. We can run this test.js. So let me run this. Node test.js, and okay, it is not printing. Let me print it. Age. Let me save this, and you can see still it is going to print the message my age. It is a dynamically typed language, and whereas TypeScript is a statically typed language. In the compile time only, the TypeScript compiler, it is going to throw the exception because you are defined one type and you are assigning one more type. That is about the first difference. Static typing. The next one is type annotations. Type annotations is nothing but the JavaScript does not support the type annotations, which is nothing but the type of the variable. In TypeScript, it provides the annotations for variables, function parameters, and even the return types. It is going to provide the annotations. So if you go to the index.ts, earlier we have written this piece of code. You can see we are adding the type number to this age, and we are telling the TypeScript compiler that this age is of type number. But in JavaScript, we cannot able to do this. We can assign any type of value to the variable. This is about the annotations. We can add annotations in TypeScript, we can add annotations for variables, function parameters, and return types. We can also look at an example. Let me remove this. I can create an arrow function const add. This will takes two parameters, a comma b, and we can provide the type as well. A, which is of number type, b, which is of number type, and also for the return type I can provide number, and I can return a plus b. And now if I'm trying to call this method add, I should pass the two numbers 2, 3. If I try to pass a string ABC, then you can see the TypeScript compiler is going to throw the exception, that is argument of type string is not assignable to a parameter of type number. This is about the second difference, which is type annotations. The other two differences are self-explanatory. Compile time errors. In JavaScript, errors can be typically caught at the runtime. We cannot able to find the errors in the compile time because, as we said before, it is a statically typed language. It is a dynamically typed language, right? So we cannot able to caught the errors at the compile time. We have to wait for the runtime. In the runtime, we can able to caught the errors. But in case of TypeScript, since it is a statically typed language, we can identify the errors at the compile time itself, so that we can avoid or prevent so many bugs in the early stage of the development. That is the advantage of using the TypeScript. And the next one is ES6 and beyond, which means the JavaScript supports ES6 features, but some of the old environments may require transpiling. But in case of the TypeScript supports all ES6 features and additional features like interfaces, enums, and it can be transpiled to older versions of JavaScript if it is needed. So that's the another difference between JavaScript and TypeScript, that ES6 and beyond. Alright, these are some of the key differences between TypeScript and JavaScript. I hope you understand the differences between TypeScript and JavaScript, why we have to use TypeScript, what are the advantages that TypeScript provides, and we will look at some of the features in the following videos as well. That's all about this video. Let's continue in the next video. In this video, let's discuss the TypeScripts. Before that, I'm going to just remove this test.js file. I'm going to delete this, and also I'm going to, let me minimize this. I'm going to start the project. npm run. We have the what we have configured, I forgot. Npm run start. Okay, yes. All right, we can able to see the text hello world. All right, now let's discuss the variables. The TypeScript also follows the same syntax as JavaScript for the variables declarations, but with some optional type annotations. So let's look at the examples. We have let, var, and const. These are the three variables that we're going to use to declare the variables. All right, now let's look at the syntax for the let, and we will add the keyword let and followed by the variable name, for example my name, and we can provide the optional type which is of string type, and I can provide the name which is Bhushan. Similarly, we also have const, and we can provide the variable name, let's say API version, which is of string type, and we can provide the version, the value v2, And next we have the var my age, which is of number type, and 32 is the value. So just like how in our JavaScript we are going to define the variables or declare the variables, in a similar way we can also declare it in TypeScript. But it takes the optional type as we can provide the type as an optional. And now we can print this. So I'm going to log this to the console, my age, my name, and API version. Let me save this and we can see hello world, 32, Bushan, and version 2. This is about the variables, and now we can discuss about these differences. We know that let is a block scoped, meaning it is only available within the block where it is defined. And also we know that the const is a fixed. Once we define the value, the value cannot be changed. For example, if I try to reassign the value to this API version, let's say v3, then you can see the compiler will throw the exception that is cannot assign to an API version because it is constant. So we cannot reassign the value once we have assigned it. The value is fixed. And also we know that what is var? The var is a function scoped or a globally scoped depending upon where it is going to define it. Generally, it is not recommended to use var. They suggest us to use the let and const, and we're going to use let and const throughout the course as well. Alright, this is about the variables. We have the same let, const, var. If you are already familiar with JavaScript, then this is not much surprise to you. Only thing is we can optionally provide the types as well. Alright, this is about the variables. Let's continue in the next video. In this video, let's discuss the different data types in TypeScript. We have the basic types, array types, tuple types, and enum types. Within the basic types, we have the number type, string type, Boolean, any, void, null, undefined, never, and unknown. These are the basic data types. Let's discuss these types one by one in detail. First, let's discuss the number type. Obviously, it is a self-explanatory. The number type represents the numeric values, but it contains both the integers as well as the floating point numbers. Unlike in any other programming languages like Java and C#, we have a different data types for floating point numbers and integer numbers. But in TypeScript, we have a single data type, which is the number type. It represents both the integer type as well as the floating point numbers. And it is declaring the number type is pretty straightforward. Let, for example, my favorite number, we can provide the optional type, the data type, and we can provide the value. For example, 100. Similarly, for the floating point numbers, let amount, and which is of number type, and 200 point some number. We can print this, my favorite number and amount. If you save this, you can see 100 and 200.2434. So this is about the number type, and for the number type we can also restrict the floating point numbers. For example, amount, you can use to fixed to restrict the number of floating point digits or the decimal points. I want to restrict 2 digits. Now if you save this, you can see it will see 200.24. It will just print the first 2 numbers starting from the decimal digits. This is about the number type. Similarly, we have the string type. String type, which is nothing but the sequence of characters, and the declaration is pretty straightforward. Let my name, which is of string type, and we can provide the value Bushan. Let's log this to the console, my name. Let's save this, and you can see it is print the name Bushan. This is about the string type. And one more thing about the string type is we can also use the template literal. For example, let my city, which is of string type, and we can use this template literal. Oops. And we can write the value, which is Bangalore, and we can print this, my city, and save this. You can see Bangalore. And one thing about this template literal is we can also include the variables. While constructing this template literal, we can also include the variables. For example, Bangalore, and if I wanted to add the my name, the variable, I can use it using the dollar, and within the curly braces I can use the variable name, which is my name. And now if you save this, you can see Bangalore and Bhushan. So this is about the template literal. The template literal is really useful when we are generating the dynamic URLs. At the time we can also include the variables within the template literal. Alright, this is about the string type as well as the number type. In the next video, let's discuss about the other data types. In this video, let's discuss the other types, which is the Boolean type. Boolean type. Also, this Boolean type is a self-explanatory. It represents the true or false values. For example, let is authenticated. I can set this to a Boolean type and I can provide the value true, and I can write a condition. He is authenticated. We can log this to the console, display the menu bar, save this, and you can see display the menu bar. So we can use this Boolean type if you ever want to set the value as true or false, then we can use this Boolean. And look at the naming convention. I have used it is authenticated. Whenever you are using the Boolean type, make sure to use this naming convention so that it will be a self-explanatory. The user will understand this variable contains the Boolean values like true or false. Similarly, you can also use has instead of the authenticated, like has authenticated or has any value, something like that. In this video, let's discuss about the any type and the void type. Let's start with any type. The any type is actually a special type in TypeScript. This variable is hold any type of value. It is useful whenever the scenario is where the type of the value is not known at the compile time. We will get to know the value only at the runtime. In that situations, we can use this any type. Like I said before, it's a special type of data type. It can hold any type of value. For example, let my favorite movie, and I can provide the type as any, and I can provide the value as a string, Mission Impossible, and I can just log this to the console, my favorite movie, and save this. It will print the value Mission Impossible, and I can just change once we define the type as any, later we can provide a different value as well. For example, my favorite movie, I can set this to a number 1, 2, 3 and save this. You can see it prints the number 1, 2, 3. So this is about the any type. It is really a special type of data type. Whenever the value is unknown at compile time, and we can use this any type. Only it will get to know at runtime. We can use this any type. It can hold any type of value. The next type is void type. This void type is generally used in the functions. Whenever we define a function, and if the function does not return any value, then we're going to use this void type. This is commonly used for return type in the functions. If the function does not return any value, then we're going to use this void type. Basically, the void type represents the absence of any value. Let's take an example. For example, I'm going to declare an arrow function const my function, and if I want to provide the type, I can provide it as void, so this will not return anything. Now if I try to return any number, let's say suppose return 2, then the compiler will throw an exception, that is the type number is not assignable to a type. Why? Because the type basically says that this function is not returning anything, and but we are returning the value 2 and it is throwing the exception. So we just log this to the console. This is returning void. Let's save this, and we can just call this function my function, save this. You can see the message, this is returning void. So this is about the void type and the any type. Let's continue in the next video. In this video, let's discuss the other types, which is the null, undefined, never, and unknown. Let's discuss the null type. The null type, which is also a self-explanatory, this represents the absence of a value. For example, let my, let's say suppose I'm running out of the variable names. Let's say suppose let my country, I can set this to null, and if I try to provide any value for this, let's say India, then it will, the TypeScript compiler will complain that is the type India is not assignable to a type null, because this null represents the absence of a value. I just have to provide the value as null. This is about the null. Similarly, we have the undefined. Undefined is also similar to null, but it represents the uninitializing the value for the undefined types. Okay, if we do not initialize any of the value, then we can say that that is an undefined. For example, let my country undefined, and if I set the value to null, then it will again, the TypeScript compiler will complain it is not assignable to a type undefined. We have to only set the undefined as a value. This is about the undefined. I hope you can understand what is undefined and null value. Similarly, we have the never, which is also a different data type which is provided in the TypeScript. See, the never type represents the values that never going to occur. For example, a function which is always going to throw an exception. In that case, we can use the never. This is useful whenever we are handling the exceptions. For example, so I'm going to define an arrow function which is handle exception, and I can define the type as never, and inside this I can throw the exception, throw error, and I can print a message throwing the error. And now if I call this handle exception and save this, you can see it will throw the exception, right? If I try to change, if I do not throw the error, if I try to return any value, let's say 2, then you can see the TypeScript compiler will complain that the number is not assignable to a type never. So we can use this never type whenever we are throwing any exceptions. At the time, this never type will be useful. This is just one scenario. Similarly, it is going to use in many other scenarios as well. Alright, this is about the never type. Similarly, we have one more type, which is the last type in basic types, which is the unknown type. Let's discuss about this unknown type. This unknown type is also a special type in TypeScript, and it represents the value that could be of any type. It is similar to any type, but it is safer than the any type, because whenever we are using this variable, if we assign it as unknown type, and whenever we are using the variable name, it is going to forcefully tell us to perform the type checking before using it. For example, let's say let my country, my country, or what I can do is my salary, which is of unknown type, unknown, and I can set this to a value 1234 1234. Now if I try to directly call a function toFixed on this my salary, let's say suppose I'm going to log this to console, my salary dot toFixed, and I want to print only 2 decimal points, and you can see the TypeScript compiler complaining that my salary is a type of unknown. So it will forcefully tell us to do a type check. So let me cut this. I'm going to write a condition that is type of my salary. I'm going to check for whether it is of number type, and if it is only a number type, then I'm going to call the function which is toFixed. Now let me save this, and we are getting some exception. Okay, this is because of this. I'm going to just comment this, and let me save this. You can see 1234.12, which means the unknown type is really useful whenever the value that could be of any type, and it is safer than the any type. Because it will forcefully tell us to do the type checking before using the value. You can easily use this in case of if you are using the any type anywhere. Instead of using the any type, you can use the unknown type. It is highly recommended by the TypeScript team or the Microsoft team. Alright, this is all about the different data types in basic types. We can discuss about the other types like array type, tuple type, enum type in the following videos. Let's continue in the next video. In this video, let's discuss about the array types. If you are familiar with JavaScript, then array types is also pretty straightforward. An array type, it represents the collection of values of a same data type. In JavaScript, once you create an array, you can provide a different type of values inside the array. But in TypeScript, once you created an array and once you define the type, then you can provide the values for the same type. You cannot provide the different values. For example, let array, let's say city names, and we can provide the type which is of string type, and within the curly braces, sorry, not the curly braces, within the square brackets, I can provide the values, for example, Bangalore, Hyderabad, and Chennai. I can log this to the console. City names. Let me save this. You can say Bangalore, Hyderabad, Chennai. And now if I try to provide a different type of value, for example 1, 2, 3, and you can see the TypeScript compiler will complain that the number is not assignable to a type which is of string type. But if I try to remove this, if I don't specify the type also, let me save this, and now you can see we can provide the value, the different type of values. Once you define the type, then you cannot provide the different type of value. You have to provide the same type of values. This is about the arrays. It is applicable to all other types, the number type, the Boolean type, and the other types that we have discussed so far. This is about the array type. In the next video, let's discuss about the tuple types. In this video, let's discuss about the tuple types. Of course, tuple type is also, let me write it, tuple type. This tuple type is also a special type in TypeScript, and it is going to represent the array with a fixed number of elements of a specific type. Let's take an example. For example, I'm going to write it as me. It is nothing, or I can write it as myself, and I can provide the type of an array, string and number, and I can provide the values for this, Bhushan, and I can provide my age, which is 32. You can see, and I can log this to the console. Let's save this. You can see Bhushan and 32. As I said before, it represents an array with a fixed number of elements of a specific type. Now here I provided the string type and providing the string value. Similarly, I providing the number type as a second index, and I'm providing the number. If I try to provide a different type for the second index, let's say Bangalore, then the TypeScript compiler will complain this. I know this is not going to understand you with this example. We can take an example of the real-time example. Let's look at the real-time example. For example, we are creating the application and we have the login form. We can create the type first, login form. Don't worry about this type keyword. We're going to discuss about this later. Just define it, string type. We have a two, for that first index, we are holding the value of string type, and the second index, we're also holding the value of string. Now I can create a variable, let login form, and which is of type login form, and now I can provide the values, let's say email@example.com, and the password, which is 12345. Now I'm going to create a function which is, let's say, function handle submit, and this is going to take the login form as a parameter, which is of type login form, and this is going to return the void type. Inside this, I'm going to destructure the values, login form and const. Now I can destructure the two values, the name and email, not the name and email, which is email and password. And now I can log this to the console, email and password. Now I'm going to just call this function, which is handle submit, and I can pass the login form. Now let me save this. You can see email and password, but now you can see we have defined this type login form, and it is going to, which is of the tuple type, right? And we are specifying the fixed number of type. The first parameter is of string type, or the first index is of string type, and the second index is of string type. And now we are destructuring it. Now if I try to destructure one more value, for example, let's say username, and you can see it is going to say that the user, the tuple type login form of length 2 has no element at index 2. The TypeScript compiler will going to compile this. Similarly, if I'm trying to provide a different data type here, let's say 1, 2, 3, 4, 5, and you can see it is going to type number is not accessible of a type string. Okay, so this is how we can use the tuple type. I know still maybe you have some confusions where exactly we're going to use this tuple type. Don't worry, you will understand this when we start building the real-time application. You will see where we're going to exactly use this tuple type. Just understand this tuple type is also a data type. It is a special type of data type, and it is going to represents an array with a fixed number of elements with a specific type. Alright, this is about the tuple type. In the next video we can discuss about the enum types. In this video, we will discuss about the last type, which is about the enum type. The enum type is also a special type. It is not a special type. Of course, it is present in many other programming languages, but it is useful for representing a collection of related values, or it is going to define a set of named constants. In that case, we can use the enum type. Let's take an example. For example, I'm going to define a set of categories. Okay. In that case, we can use enum category, and we can provide the category names, for example, entertainment. Similarly, we have to provide with the comma separated values. Similarly, we have movies, and one more category which is lifestyle, and similarly we have food. And now I can create a variable. Now we have defined this enum. We have 4 constants: the entertainment, movies, lifestyle, and food. Now I can use let selected category, which is of enum type, a category type, and now I can provide the value, for example, category dot, let's say, lifestyle, and I can log this to the console. Selected category. Let me save this. You can see it prints the lifestyle. So whenever, if you want to define a set of named constants, then in that case we can use the enum type. Alright, this is all about the data types in TypeScript. We have discussed about the basic types. In basic types, we have the number type, string type, boolean, any, void, null, undefined, never, and unknown. Also, we discussed about the array types, tuple types, and enum types. Let's continue in the next video. In this video, let's discuss about the function overloading, or also called as method overloading. Just like in any other programming languages, TypeScript also provides the function overloading. Function overloading, which means defining the multiple methods with the same name, but there is a difference in the parameter list, or the type of the parameters, or the order of the parameters. But there is a slight difference in this TypeScript function overloading. In other programming languages, we are going to provide the implementation for each and every method. But here we are going to define multiple signatures, but we're going to provide a single implementation that handles all the possible argument combinations. We will provide a single implementation that should handle all the possible combinations. Let's take an example. For example, I want to print a log to the console based upon the argument type. So I'm going to define a function log. This is the method name, and this will take the string as a parameter, and this is going to return void. Similarly, I'm going to declare one more function with the same name, log, and this is going to take the object as a parameter. This object is also a one more type, and this is going to return void. Similarly, let's define one more method with the same method name. This will take the status code as a parameter, which is of type number. This is going to return void. Now we need to provide a single implementation method for all these 3 combinations. So let's declare a function log, and this will take the argument as a parameter, which is of type any, and this is going to return void. Now we can provide the implementation for this, or also we can specify the type, which is void. That's completely fine. Inside this, now we can write the condition. If we can check for the type, if the argument, the type of argument is equal to of string type, then we know that user is trying to call this function. In that case, we can just log to the console. This is a simple message. We can write one more condition, else if the type argument is of type number, Then we can log the console. API response. API response is we can concat, or we can make use of this template literal. We can concatenate the argument, which is nothing but the status code. And also we can write one more condition if there are any. Let's say suppose we have this object type, right? So we can write this object type using the else if, but in this case we can just write the else condition, and then we can log this to the console. If the user is passing any object, then we can convert that into a stringify. So we can make use of this json.stringify, and we can pass this argument. Now at the bottom I'm going to call the functions, which is log. First I'm going to pass the string. Let's say I'm going to pass the bushan. Similarly log, and I'm going to pass 201. Next log, I'm going to pass an object. Let's say name bushan, age 32. Now let me save this, and you can see we get a different outputs. First we get the simple message, and we get the API response is 200, and we get the object, right? Okay, I think this we have to make it as json.stringify, and we're passing it as, okay, this is should be, let me cut this and get rid of this. Let's call this log function, and to this we can pass the object. Now let me save this, and you can see now we have converted into as stringify. We get the API response as 201, and this is a simple message. So what I'm trying to prove is in TypeScript also we can define a multiple methods with the same name, but there is a difference in the argument list or the type of the arguments. And then we can provide a single implementation which should work for all the combinations, and then we can do our performance, we can do our operation. So here we are trying to log the message to the console, and we are checking for the type of the argument, then based upon we are printing the messages. You will understand the real use case when we start building our application. So this is about the function overloading. Let's continue in the next video. In this video, let us discuss about the classes, objects, and constructors in TypeScript. In TypeScript, class represents the blueprint, which is nothing but a class represents the structure of the real world entity. Let's take an example. We want to define the structure of the ATM machine. So in TypeScript, we're going to define it using the class, and to create a class in TypeScript, we're going to use the keyword class followed by the class name. In this case, it's ATM machine. Inside this class, whatever we write, that is called as members of the class. Inside this class, we're going to define the properties, are also called as member variables, are also called as just variables. We also define behaviors, are also called as methods, are also called as functions. Inside the class, we define the variables and methods. For example, this ATM machine contains the properties such as name of a person or a name of a customer, and it also contains the account number, which is of type number, and the initial balance, which is of type number. This is about the structure of the ATM machine. It also contains the behaviors, nothing but the methods. Let's define a method. For example, this ATM machine also provides the functionality to withdraw the money or check the balance. We can define the method such as check balance, and we can return the balance. Next, we can also define other behaviors. For now, let's keep it simple. So now we define the structure of the ATM machine, which is nothing but the blueprint. And we designed this structure using the class. This is not enough because just creating the blueprint is not going to happen anything. We need to create an instance of it. For that, we are going to create an object out of this class. Objects are nothing but the real world entity of this blueprint. Once we create the blueprint, we need to create an instance of it. For that, we're going to use the objects. We're going to create an object out of this class. How to create the objects? We're going to make use of the new keyword, and then we're going to use the class name. Let's take an example. Let's call this variable name SBI machine is equal to, we're going to make use of the new keyword, new followed by the class name ATM machine. Whenever we use this new keyword and we call this class name, then we are creating a new object of this ATM machine. And whenever we create a new object, a special method will be called, which is nothing but the constructor. So every class contains a constructor. The job of the constructor is to initialize the values to the variables or the properties. In this case, we have 3 properties. So as soon as we create a new object of this ATM machine, it is going to initialize the values to this name, account number, and balance. Let's provide the values, the initial values. Name, which is of type string. Next, we have the account number, which is of type number type, and we have the balance, which is of type number type. Now we need to assign these values to the member variables. So we can make use of this keyword. This keyword represents the current class. So this dot name is equal to, we're going to assign the name that we are passing from the constructor. Next, this dot account number is equal to account number. Next, this dot balance is equal to balance. Now, when we create a new object of this ATM machine, we are going to pass the initial values, or we are going to initialize the properties, which is name, account number, and balance. So let's pass the initial values. The name, which is Bhushan, and account number, let's say 12345, and the balance, let's say 10,000. Alright, now we created the object out of this ATM machine. We can print this. Let's log this to the console, SBI machine. Let's save this, and you can see it print the values, name, account number, and balance. We just created one object. We can create any number of objects using this class. As I said before, this class defines the structure of the ATM machine, and now using this blueprint or using this class, we can create any number of objects. For example, I'm going to create one more object. Let's copy this and paste it. Oops, let me copy this and paste it, and let's change this to HDFC machine, and I can provide a different values. Let's say Bharat, his account number is one something else, and we can just provide the balance, let's say 20,000, and I can print this also. Let's change this to HDFC machine. Let me save this, and you can see it prints the another object as well. So what we understand out of this is, whenever if you want to represent any real world entity, if you want to define the structure of the real world entity, we can define it using the class, and then we can make use of then we can create an object out of that blueprint, and we can initialize the values through the constructor. This, and I'm going to log this to the console and save this, and you can see it prints the balance, which is 10,000. So this is how we can, using the object, we can call the behaviors as well as the properties. We can also print the individual properties. For example, I'm going to just print the name of the customer. So let's copy this and paste it, SBI machine, and I can just print the name. Let's save this, and you can see it just prints the name of the customer. Alright, this is all about the classes, objects, and constructors, and how we can call the member variables, and how we can initialize the member variables using the constructors. Let's continue in the next video. Similarly, we can also call these behaviors. First of all, I'm going to add the type annotations. The check balance is going to return the type number. And here we can make use of this SBI machine to call the behaviors or the methods. In this case, it's check balance. And I can log this to the console as well. Let me cut this and I'm going to log this to the console and save this. And you can see it prints the balance, which is 10,000. So this is how we can, using the object, we can call the behaviors as well as the properties. We can also print the individual properties. For example, I'm going to just print the name of the customer. So let's copy this and paste it, SBI machine, and I can just print the name. Let's save this and you can see it just prints the name of the customer. Alright, this is all about the classes, objects and constructors, and how we can call the member variables and how we can initialize the member variables using the constructors. Let's continue in the next video. In this video, let's talk about the inheritance. TypeScript supports inheritance, which means we can create parent class and subclass, and the subclass can inherit the properties and behaviors from the superclass. Let's take a real-time example. The people who are living in India can easily relate to this example. I'm going to define a class which is HDFC Bank. It is a private sector bank in India. Class HDFC Bank. I'm going to define a method which is create account. This is going to return void, and inside this we can just log a message, account is created. And also I'm going to define or going to create a property which is account number, which is of type number, and I will create the constructor. This will takes the account number as a parameter. We can initialize the property. This dot account number is equal to account number. Now I can just log this account number to the console as well. This dot account number. Now whoever going to create a branch from this HDFC Bank, they also need to inherit the properties, which is the account number and the create account, because creating the account is common for every branch. Whoever going to create a branch, the new HDFC branch, they should also provide a support for customers to create a new account, right? In that case, we can create a subclass. Let's create the subclass, class branch 1, and this will extend the HDFC Bank. And now inside this we can just create a constructor and we can supply the account number, which is of type number. Oops, let me change this to colon, and we can, now we need to pass this account number to the parent class constructor. For that we are going to call the super method, and to this super method we are going to pass the account number. Now if the customer from the branch 1, if the customer want to create an account, they can easily create the account. For example, let's create an object. Let new customer is equal to new branch 1, and we can create a new account for the customer 1 2 3 4 5. And now we can, let me make use of this new customer dot, we can call a method create account. Now let me save this. You can see account is created 1 2 3 4 5. Similarly, I can create a one more branch 2, that will also extends the HDFC Bank, and I can create a constructor and I can just pass the account number, which is of type number type, and I can call the super method and I can pass the account number. Similarly, we can, one more customer from branch 2, he can create a new account. Suppose this branch 2 contains a one more provided a one more facility to the customer, which is they provided the car loan. Let's say get car loan, get car loan is going to return void, and now they're going to provide the car loan with the interest rate which is of number type. And now what we can do is we can directly assign this to the this dot interest rate, and I can use this interest rate, and I can define the variable, the property, which is interest rate, which is of type number type. Now we have to initialize this. So what I can do is I can just pass this interest rate here, interest rate, which is of type number type, and now I can assign this dot interest rate is equal to interest rate, right? Now, or let me get rid of this, we don't need this. I can just log this to the console. We are providing car loan, and I can access the interest rate. Okay, now the new customer from the branch 2, let's create a new customer from branch 2, new branch 2. They can also create a new account, let's say 1 2 3 4 5 6 7 8, and they can also opt for the car loan, which is of interest rate, let's say 10.5. Now I can use this new customer from branch 2, and I can call the create account as well as the, let me copy this and paste it, and we can call the get car loan. Now let's save this. You can see account is created for the branch 1 customer, and branch 2 customer account is created. Also they are opting for the car loan, which is with the interest rate of 10.5. So this is how we can make use of the parent class and subclass. The subclass can inherit the properties from the parent class. Also the subclass can contain other additional properties and the behaviors. See here, the branch 2 contains the car loan, which is another feature that is provided by the branch 2. So this way we can reduce the code. This inheritance provide the code reusability. This is about the inheritance. Let's continue in the next video. In this video, let us talk about the method overriding. TypeScript also supports method overriding. Method overriding is nothing but the subclass can override a specific implementation which is already defined in the superclass. For example, let's take the previous example. I'm going to slightly modify the previous example. Instead of the HDFC Bank, I'm just going to make this as main branch. Let me change this to main branch. Also, I'm going to change this to main branch. The main branch also provide a feature for car loan. Get car loan is going to return void. Can provide the implementation. Just log this to the console. The main branch provides the car loan with an interest rate of 12%. We provide car loan with interest rate of 12%. Now the branch 1 and branch 2 can override this get car loan method, and they can provide their own implementation, because the branch 1 may give a car loan with a lesser interest rate and branch 2 can give a car loan with much lesser rate. In that case, we can override the method which is the override the implementation which is provided by the superclass, and they can provide their own implementation. So let's see how we can do that. In order to override the method, the rule is the subclass can contain the same method name with the same argument with the same return type. Then only we can override the method. For example, let me, in the branch 1, I'm going to just call a same method get car loan with the same method name with the same return type. And now I can provide a different implementation. Just log this to the console. We provide car loan with 11% interest rate, with 11% interest rate. Similarly, the branch 2, can we are providing the car loan with, let me remove this, let's keep it simple. We are providing the car loan with 9% interest rate. Let me save this. Now what I'll do is, for example, we have the new customer for branch 1 and new customer for branch 2, and let's say suppose if someone is taking a loan from the main branch, let's say main branch is equal to new main branch, they should first create an account, main branch dot get car loan. Let me save this. You can see they get the car loan with we provide the car loan with an interest rate of 12%. Similarly, now the branch 1, which is new customer dot get car loan. Let's save this. You can see we are providing the car loan with 11% interest rate. Similarly, the branch 2, they provide the car loan with an interest rate of 9%. So this is how we can override the implementation, the specific implementation which is already defined in the superclass, and the subclasses can provide their own implementation. Here the branch 1 and branch 2, they are providing the different implementation for the same method, which is get car loan. They are providing a different type of implementation for this, and the rules for overriding the method is everything should be remain same. The method name, the return type, argument, even the sequence of the arguments, everything should remain same. Alright, this is about method overriding. Let's continue in the next video. In this video, let's discuss about the abstract class and abstract methods. TypeScript also supports abstract class and abstract methods. We can make a class as an abstract class. And if you are making a class as an abstract class, then there should be a one method that should also be an abstract method. If any method is abstract method, then that class should also be an abstract class. And once we make that class as an abstract class, we cannot create the object of that class. Only the child classes or the subclasses can create the object of it. Let's take an example. For example, I'm going to create a class with a name RBI, which is Reserve Bank of India. Now I'm going to make this as an abstract class. Once we make this class as an abstract, there should be a one method which should also be an abstract method. And abstract method does not have any implementations. The child class or the subclasses who are going to extend the abstract class, they have to provide the implementation for this. In this case, let's say suppose the Reserve Bank of India is provided the method which is create a bank account, and whoever going to extend that class, the RBI class, they have to provide the implementation for the creating a bank account. So for that, I'm going to declare a method which is an abstract method, which is create account. This is going to return void. And as I said before, the abstract method does not have any implementation. Now I'm going to create a class which is, let's say, HDFC Bank. This is going to extend the RBI Bank. So the class RBI, and you can see it will shows the error, that is non-abstract class HDFC Bank does not implement the inherited abstract member create account from the RBI. So we have to fix this. For that, we have to override that method. We have to implement this method which is create account. Inside this, we can provide our own implementation. Let's say creating bank account for HDFC Bank. Similarly, I can also create one more class which is SBI Bank extends RBI, and we need to override the method which is create account. This is going to return void, and we can provide the implementation. Just log this to the console. Creating bank account for SBI Bank. Now if I try to create an object for the RBI class, let's say let RBI is equal to new RBI, and you can see we get the error, that is cannot create an instance of the abstract class. We cannot create the object for the abstract classes. We have to create an object for the subclasses. In our case, the subclass is HDFC Bank or the SBI Bank. Let's create it for HDFC Bank, and we can create a new HDFC Bank. And now we can call the method which is create account. Let me save this, and you can see the message creating a bank account for HDFC Bank. Similarly, we can also create the object for SBI Bank. We can make this as SBI Bank, and let's change this to SBI Bank, and let me save this. You can see the message creating a bank account for SBI Bank. So this is how we can use the abstract class and abstract methods. This is very useful whenever the scenario where we wanted to forcefully provide the implementation for the child classes, but where the parent class does not have any implementation to provide. In such situations, we can use this abstract class and abstract methods. Basically, the abstract methods does not have implementation. Who are going to implement, who are going to extend that class, they have to provide the implementation for that. Also, we can also create the constructors, and we can pass the parameters to it. That is completely optional. I also forgot to say one more thing. The abstract class also contains the regular methods. It does not contain only the abstract methods. It also contains the regular methods. Let's say create one more method, which is check balance, and this is going to return a number type, and I can return, let's say, $1,000. And let me save this. Now who are going to the SBI bank or the HDFC bank, anyone can call those methods. For example, HDFC bank dot, it can call the method check balance. Let me save this, and you can see creating the account. And okay, we are just returning this. I'm just going to log this to the console. Check balance is called. Let me save this, and you can see check balance is called. So the abstract class can also contains the regular methods. It does not that only the abstract methods it will contain. It also contains the regular methods with the implementations. But if we make a class as an abstract, then there should be one method which should be an abstract method. Alright, that's all about this abstract class and abstract methods. Let's continue in the next video. In this video, let's talk about the interfaces. In TypeScript, we will create the interface to define the structure of the class or object, including its properties and methods, without providing the actual implementation. These interfaces are really helpful. It ensures that the class or an object should follow a specific structure. We're going to use this interface a lot in the React applications to define the structure of the component, to define the structure of the object. You will see the real use case as we go further in the course. But for now, let's take an example. In order to create the interface, we're going to use a keyword interface followed by the interface name. Let's say I want to define the structure of the bank, and the bank contains the account number, which is of type number, and it also contains the customer name, which is of string type, and also it contains a method which is check balance. It is going to return void. Now we need to create an object for this bank interface, and who are going to create the object, they have to follow the structure of it. So I'm going to create an object, bank object, which is of type bank. Inside this, we have to provide the values for the account number, let's say 12345, and customer name, let's say Bhushan, and we have the method check balance, and we can log this to the console, checking the balance. And now we can print this. I'm going to log this to the console, bank object. Let me save this, and you can see it will print the object. And for this function, we can do bank object dot, we can call this check balance method, and let me save this, and you can see checking the balance. Okay, so we can remove this console.log. Let me save this, and you can see checking the balance. Now if I try to remove any one of the property, you can see it will throw the exception, that is property account number is missing. We have to provide the account number as well, because we have defined it. This bank object should contain these properties, and we have to provide the values. Let's say suppose any one of the properties optional. What we can do is we can provide a question mark next to the where property name. Then in that case, the compiler, TypeScript compiler, assume that this is an optional property. Now in this case, we are not getting the errors. We can completely make this property as an optional by adding the question mark. Alright, this is all about the interfaces. We're going to use this interface a lot while creating the React components. Let's continue in the next video. In this video, let's talk about the static properties and methods. In TypeScript, we can apply static keyword for properties as well as the methods inside the class. And once we applied the static keyword, we don't have to create an object for the class to use those properties and methods, because these are the properties and methods that belongs to the class. Directly using the class name, we can access the properties and methods. We don't have to necessarily create the object of it. And let's take an example. For example, I'm going to create a class which is app utils. Inside this, I'm going to define the base URL for the application. I'm going to call this first I'm going to add the keyword static. I'm going to make this field as a static, and I'm going to call this base URL, which is of type string, and I can provide the base URL, which is http://localhost:8080. Now in order to access this property, I can directly use the class name. I can just log this to the console, apputils dot, you can see we can access this base URL, and let me save this, and you can see it will print the value. Similarly, I can also make a method as a static. I can call a function which is get expenses resource, and I can return the resource URL, which is /expenses. Now I can directly use the app utils to call the method, which is get expenses resource, and let me save this, and you can see now we have formed the URL http localhost:8080/expenses. Since we created the class, we are not instantiating the class, we are not creating an object for the class. We have made this method and field as a static, so that using the class name we can directly access the properties as well as the methods. Whenever if you want to create any util methods, or if you want to create the constant fields or anything, we can make use of this static keyword. Alright, this is all about the static keyword or the static properties and methods. Let's continue in the next video. In this video, let's talk about the imports and exporting modules in TypeScript. In TypeScript, using the import and export modules, we can share the code between the files. This will help us organizing the code. Let's take an example. I'm going to create a new file inside the source folder. I'm going to call this expense.ts, and inside this expense.ts, let's define a function. I'm going to call this get expenses. This is going to return the void type, and I can just log this to the console, reading the expenses. Now if I want to export this function from this module, what we can do is we can just use the export keyword, and now we are exporting this function. Once we export this function, wherever in our application, we can import this function using the import keyword. First of all, a module is nothing but every TypeScript file. We're going to call this as a module. Okay, now inside the index.ts file, I'm going to import it, and within the curly braces, we can provide the function name, and also we have to provide the path name using the from followed by the path. We need to provide the from where we are importing it, from the expense.ts file. We don't have to specify the extension, and now you can see we can import the get expenses, and we can directly call the function get expenses. Let me save this. You can see reading the expenses. So this way we can export the function and we can import it. We can export any number of functions. Let's say I'm going to export one more function, export function create expense. This is going to return void. I can just log this to the console, creating the expense. Let me save this, and now inside the index.ts with a comma separated, we can import the one more function, which is create expense, and we can call the function create expense. Let me save this. You can see reading the expenses and creating the expenses. So this is how we can import and export the functions. And now let's see how we can export the default functions, or inside the expense.ts. What we can do is, let's say suppose if we have a single function, we can just export it as a default function, and we can just add the default after the export keyword. And inside our index.ts, first of all, let me remove this, create, and now we don't have to, inside the curly braces, we don't have to import it like this. We can just directly import it with get expenses. And now let me remove this, let me save this, and you can see reading the expenses. While importing, if we are exporting it as a default function, while importing it, we can import it with any name. For example, I'm going to just import it as test, and now if I do test, let me save this, you can see still we see the message reading the expenses. So this is about the default exports. And now we understand about the earlier what we have used is that's the named exports, because we are using the name, we are exporting it. Now this is about the default exports. Alright, this is all about the import and export. When we are working with our React project, we're going to use this import and export a lot. Let's continue in the next video. In this video, let's discuss about the union type in TypeScript. This is the last type that we're going to discuss, and then we're going to wrap up this section. This union type is a special type in TypeScript. It allows us to, whenever a variable can hold a multiple type of value, then we can use this union type. This is useful whenever a value can hold a different type of values at different scenarios. At the time we can use this union type. I'm going to declare a variable, let's say expense ID, and we need to provide the types with a comma separated. For example, this expense ID can be of type number type, and we're going to separate it with a pipe symbol, the different types. It can also be of string type. And now I can assign the values. Let's say expense ID, I can assign a number type, let's say 19, and I can log this to the console. Expense ID, let's save this. You can see it prints 19, and I can also assign a string type, let's say expense 123, log this to the console, and I can print the expense ID. Let's save this. You can see it prints 19 and expense 123. So this is about the union type. Let's take one more example. I'm going to declare a function get data based on expense ID. So now user can pass two different types. For example, I'm going to provide the variable name which is expense ID, which is of type number type. It can also be of type string type. In this case, let me log this to the console, fetching the data based on expense ID, and I can print the expense ID. And now let me call the function get data based on the expense ID, and I can pass the number type, let's say 123, and save this. You can see fetching the data based on the expense ID. Similarly, I can also pass the string type, because this is a union type, and I can pass expense some numbers, and let me save this. You can see it fetches, it prints the message. Alright, this is all about the union type. You will see the real use case when we start creating the real world project. Yeah, this is all about the union type. Let's continue in the next section.